we're going to look at the dot product, another application we can use for it. Here, we're going to look at this point, which is not on this line. And we're going to actually use the dot product to find how far away this point is from that line, how close it gets. So one thing to remember, the reason this is useful is that or the reason this is possible, is you have a line and a point not on it, the shortest distance always goes on a path that's at a right angle, i.e. perpendicular to the original line. So if we can find the path that's perpendicular from here to there, we're all right. And as we discovered last time, perpendicularity is shown by a 0 in the dot product. So this is Q, this is 2, 36, -5. And this is some point P on R1. Now point P, we have coordinates for actually. It's 2 plus 4 lambda, 1 take 9 lambda, -4 plus 3 lambda. It's just that as a single vector. Now, to get from one vector to another, it's a subtraction. To get, you go back to the origin and then there again. So we actually take away Q. This just comes from our basic vector geometry. Subtracting vectors gets us the vector from the second to the first, QP. So that gets us 4 lambda, -35 take 9 lambda, 1 plus 3 lambda. So this thing here is this vector here. All right. And we want that right angle, which means that this dotted with the direction of that should be 0, and that there is the direction of that. So what we need to do is this 4, -9, 3 dotted with 4 lambda, -35 take 9 lambda, 1 plus 3 lambda. And that gets us 16 lambda plus 335, 315, take 81 lambda. That should be take, shouldn't it? Oh no, that's -9. -9 times -5, yes. Plus 3 plus 9 lambda. And that simplifies to be 106 lambda plus 318. Now, because that's perpendicular, this should be equal to 0. So we rearrange this and solve this, and we get -318 over 106 is lambda, which actually is -3. So lambda is -3. So this vector here is that vector there. So if I could put -3 in here, I'd know what QP actually is. So it's going to be 4 times -3, -35 take 9 times -3, 1 plus 3 times -3. And that comes out to be -12, -8, -8. So the size of QP, to finish off, is just a bit of Pythagoras. So stick that through a calculator, you get 272, which is exactly 4√17. All right, so the principle here is that the shortest distance is the perpendicular distance. So if we can characterize this vector as a single thing, we can then dot that with the direction, solve for 0, bada boom, bada bing, Pythagoras to finish it off. I hope that makes some kind of sense.